Okay, so now we're going to talk a little more about UV coordinates and texture sampling. So I'm going to create a new base. And I'm going to call it UV and textures. And I do the same again. I create a GLSL top. So if you don't get the info that, you can follow the steps before to recreate it. So in the default code, the sample code, you had a line that is commented, which is this one. So what we're going to do is we're going to uncomment it. And we're going to delete the line below. And we're going to save. And now we're getting an error. So what it says is undefined variable std2d inputs. And if you middle click, it's just compilers. So the texture functions allows you to sample an input texture and to use it for the pixel value. And so you need two things. You need kind of the name of the texture and the coordinates. So this is provided by TouchDesigner, std2d input. So it's like sampler, TouchDesigner. It's a 2D one. So we're going to create, let's do a movie file in. And so 0 is the first input. If you put 1, it would be the second input. If you put 2, it would be the third input. So we're just going to connect the first one. And now the error goes away. So the thing is that it's not defined if there's nothing connected to it, which is why you don't need to change the code, but you just need to connect it. Because then in the background, TouchDesigner kind of defines this variable, and you can access it. So by default, it's just going to literally copy the input image. I'm going to pick another one. I'm going to pick oil drums. Oops. Yeah. So now we're going to talk a little about UVs. So if we go back to our 2D image, so UV are coordinates, and they start at 0 here, and they go to 1 here, and same here. So that's 0, 0. Here it's 1, 1. And in the middle, so 1, 2, 3, 4, 5. Up, 1, 2, 3, 4, 1, 2, 3. So kind of in the middle would be here, and that's 0, 5, 0, 5. So these coordinates, they're normalized, so they go from 0 to 1. Whatever the pixels you have, even if it's like HD, 1080, 1024, whatever, it always goes from 0 to 1. And a nice way to kind of, you can visualize them. So what you can do to visualize them is you can say color equal, so we want a vec4. And then you can do vuv.st. We only care about x and y, and then 0, and we just want fully opaque, so 1, and save. And now we get this, this gradient. So if we want to make it even easier to see, I can do color.x equals 0. So now I'm just visualizing the first coordinate. And so you can see it goes from black to red, so it goes from 0 to 1. And if you do color.x equals 0, you can see it goes from 0 to 1 vertically. And so if we just use the default, so this is how we're going to be able to display different values for each pixel. It's using these coordinates, which are different for every pixel. So if we just want to copy the input image, we just want to sample things from 0 to 1, so the whole image in the same spot. So this is something that is provided by TouchDesigner. And we're going to see how when we deal with geometry, it's going to be called differently. But for now, when you do GLSL tops, you always have access to vuv.st. And s goes from 0 to 1 in x, and t 0 to 1 in y. So now what you can do with that is, let's say you want to scale the input image. You can multiply them. So I'm going to define a vec2, and I'm going to say it's called my UVs. And I'm going to say it's 2 times vuv.st. And now I'm going to say, I'm going to override color with my new coordinates. And save. And now you can see it made the picture 2 times smaller. So 2 times in x, 2 times in y, so it's kind of 4 times smaller. And the rest is empty. So it's kind of inverted because now we go from 0 to 1 from the corner to the center of the picture. So now is a good moment to kind of talk more about the input extend mode. So by default is 0. So it means that when UVs are bigger than 1 or smaller than 0, then it's just going to display 0. But instead, if you choose repeat, now you can see it's just repeating the input picture. Because when it's between 1 and 2, it's going to kind of subtract 1 and start again at 0. And if
what is the second variable of textures?
So it's the coordinates. Huh? The coordinates is where.
Oh, gotcha.
So here we're writing 1 pixel, and this pixel we're saying it, oh, you need to look up in the input picture at this coordinate. And this gets executed for every pixel, and that's why each pixel has like a different input pixel from the input picture, and that's reconstitute the whole picture.
Would that also work with XY?
Sorry?
Would that also work with XY?
Yes, totally. So yeah, so if I comment this new line and put XY, so you can see XY or ST are the same. And the thing is, VUV, it's not a vec2, it's a vector 3. Because when you're dealing with 3D texture, the P coordinate is used. So that's why you need to do point ST. And if I remove it, it's going to give me an error because it says implicit cast from vector 3 to vector 2, which means instead of giving him a vector 2, we're giving him a vector 3. So when I defined my new coordinates, I said it was a vector 2, and that's why I can just use it as is. But I could also like add .xy here, and it doesn't make any difference. So to continue with the extend mode, so there is hold. and hold is just going to repeat the last pixel value and extend it. So you can do like a lot of like kind of nice reveal effect with that. And mirror, it's going to, instead of just repeating, it's going to mirror the coordinates. So I'm going to show again quickly. So I'm going to show my custom coordinates. Forgot the S. So you can see now so these are the defaults, and these are the new ones. Yep. And what I can do to kind of see how the coordinates move on this rectangle is drop down at top 2. And so by default, it's sampling a line. So what we're seeing is like the pixel value for one line that goes from 0 to 1 in X. So only the first component is moving, is up. So I'm going to kind of remove all of them. And now you can see it stops at 1 and then stays at 1. And that's, again, because we're using 8-bit fixed. So fixed means everything is going to be clamped between 0 and 1. And if we change the type to 16-bit float, so now you can see I go from 0 to 2. And so it's going to, from 0 to 1, it's going to sample the picture. And then from 1 to 2, it's going to sample the picture again. And it's going to use the input extend mode because we're outside of the 0 to 1 range.
Is it good to set your GLSLs to 16-bit float just automatically to get more info out of it? Or is it
only if you need it. Because in general, it's going to use more GPU memory. And it's also going to be slower to do the operations. So it's nice. So to do this kind of debugging, it's useful. Because then you can visualize the actual values outside of 0 to 1. But if you're just like doing kind of image processing, usually you won't need it. So if you want to see, you can see GPU mem desktop. So that's the GPU memory it's using. So when it's 16-bit float, it's 7 mega. And if I go back to 8-bit fixed, now it's only 3.5 mega. So if you have like a lot of big textures, it's like you're gonna run out of memory pretty quickly if you use a 16-bit float. So manipulating kind of texture coordinate, you can do all sort of like interesting effects. So if you go to the palette and you go to, I think it's, sorry, can never find it. Oh yeah. So image filters, and you select Trill. So the palette, if you don't know where it is, it's this little icon. You can like show it and hide it. And it's like a lot of like little tools that are built with touch that are made by the derivative team and that are like not always super useful, but like kind of nice techniques. So you just drag and drop here. And I'm going to connect my my picture here. And you can see I get this nice little swirl effect. And they like set up like a couple of parameters. And if you go inside, you can see the actual effects uses GLSL code to do this this deformation. and it's like manipulating the UVs to do it. So as an exercise, we're gonna like do a little deformation of our own. So I'm gonna show the output picture again. And I'm gonna hide the top two. So let's say we want to, if I do, so let's say we want to kind of do like a bulge effect. So when we're like further from the center, the pixels are gonna get pushed more. So what we want is, so when we're here, the effect is 0. And as we go further, we're gonna kind of displace the pixels based on how far they are from the center. And then we're gonna add a uniform to kind of control the effect. So the first thing we need is to calculate the distance from the center for every pixel. So the way to do that, no, we want first we want the direction from the center. So if you don't, so we're gonna do a bit of vector math. So we just need to subtract the coordinates. Oops. So when you have 2 points, and this one is x1, y1, sorry. And this one is x2, y2. So if you want this direction, it's going to be x1 minus x2 and minus y2. But you can also just kind of subtract this vector 2 from this vector 2. So the center is going to be 0.5, 0.5. So we're going to declare a new vector called center. And we got to say it's a vector 2, 0.5. And now we're going to say a new vector 2 that's going to be called direction from center. And we're going to say, so vuv dot st minus center. And the other thing we want is the length, the distance from the center. And we're going to do a float, which is going to be called distance from center. And you can use the built-in function length and give it the direction from center. And now we're going to do my UVs equal, so vuv.st Yeah, sorry. Actually, we don't need this one. And we're just going to add the direction from center. So now we get this. And to kind of understand better what's going on, we are going to create a uniform to kind of scale the effect. So I'm going to create a uniform, a float, and call it U effect scale. And I'm going to multiply this using my scale. So now by default it's gone and it's complaining that the uniform is unassigned. So I'm gonna create my uniform. And so what you see, it's like, so far it's not very interesting because it only acts like a kind of general scale factor, because we so when you like negate it, you can see it like zooms into the image. And when you like go bigger, it's like gonna kind of shrink into the image and repeat it. So to make the bulge effect what we want, we need to normalize this direction from center. Because at the moment, yeah. Yeah, because at the moment it's like fully proportional. So this pixel are gonna get, this pixel is gonna get pushed like twice as much as this pixel. And what you can do, you can just add normalize. And normalize, it makes it direction, and everyone has the same length. And now you can see, oops. And now you can see we're getting our kind of weird kind of pinch wheel effect.
Sorry, why did you normalize it?
So what you want is only, you just want to push the pixels just based on their kind of their direction compared to the center. And let me try and explain it better. So if we take this pixel, I'm gonna erase all these arrows. So that's our center. That's a pixel that's like halfway, and so that's the direction from center we're calculating here. So if you add this value to this one, it's gonna put this pixel here. It's like reversed, but and if you take this pixel, so that's like the tier. And this one, if you add the value that you calculated, it's gonna push it like here. So what you get basically is just like gonna be a scale effect. And on the other end, if you normalized, then so if you normalize, this pixel is going to be pushed by this amount, and this pixel is going to be pushed by this amount. And so you're going to get the deformation we're seeing.
Okay, so the
normalize make all the vectors 1 unit long. Yeah,
Gotcha.
sorry. So if you, yeah.
When you have a vec2, you just have one value vector.
Um,
Why is that?
yeah, so you can, if you only give one value, it's gonna initialize all the components with the same value. It's like a shortcut. So you can do it with a vector 3 and a vector 4, and it's also gonna work. So if you want to like kind of know more about the built-in function, you can Google GLSL normalize. And always first you're going to see the OpenGL4 reference. And so it's see normalize returns a vector with the same direction as its parameter v, but with length 1. So you can like easily find. And another thing I think I talk about it later, but you can type OpenGL reference card. And
It's not a reference card. It's like a reference manual.
it's bigger than expected, but if you scroll to like further down, you get to built-in functions. And so, well, it's kind of like an overview of like all the built-in functions. So normalize is in there somewhere. Yeah. Oops.
It's in multiple places.
Yeah, it's in geometric function. So these are like all the functions to like kind of do math with vectors.
So you're saying the TFD normalize is looking. That's the actual function that we're using.
Yeah.
Okay.
So TFD, yeah, so it's because you can use float or double, which are float but with more precision. So TFD stands for, it can be either float or double, but it's the same function.
So normalize, does it make the highest value to 1 in the set of values you set to it?
So what it does is,
Use all the values between 0 and 1.
Right,
So
yeah.
0 and whatever value you
It's 0 to 1,000, 1,000 becomes 1, and whatever in between becomes.
Exactly.
yeah, so just like, so that's my vector and so it's x, y. So the length of this vector is going to be square root of, and so what you do is you kind of divide the x, you divide the x coordinate by this, and you divide the y coordinate by this. That's what normalize does. Sorry, it's like a little messy, but yeah. Anyway.
Question for you.
Yep.
With the OpenGL reference card, for us, some of us that are using Mac, would we have to go to a different version of the reference card?
That's a good question. What version do you have in Mac? What's the
3.30.
Yeah, so I think you can just here if instead of is it gonna work? No.
It was only so.
OpenGL reference. I think it's probably still somewhere, but we have the 3.2.
There's 3.3.
There's 3.2. Yeah. Seems to like.
No longer a reference card.
Yeah, that's the spec. Yeah, it seems the closest is gonna be the 3.2.
All right, cool.
Yeah, I think it's more for like compute shader stuff that's you're gonna have more difference. For this, it's gonna be like the same, like 4.5 or 3.3.
Oh, okay, cool. But if we run into compatibility issues, this is the card that we should use.
Yeah. Okay, and so now maybe as a quick exercise, let's try and animate the center. So the kind of swirl effect kind of moves around. I'm gonna like kind of walk around, see if like everyone is good, and like you can start to do that.
So you can either run
Yeah, just a quick tip.
yeah.
So that's why I recommend. I know Mac users are not big fans of mice, but a lot of the interface is thought with the mouse's mind. So if you middle click, you're gonna get this little ladder, and then if you hold and kind of move right, you see it's like a quick way to kind of animate the parameter. And so if you're 0.1, the step is going to be 0.1. If you're 0.001, the step is going to be 0.001. And yeah, so just a quick useful thing. One thing is you want to save your file before you want to save your file regularly, because sometimes the mouse kind of gets stuck, and then the only way to kind of get it back is to quit and restart. So yeah. Yep. Sorry, I'm just going to go back there and come back to you. So I got a question about texture, the function. So if you Google texture GLSL, you get the reference. And you can see you have kind of all these variations. And the one we're using is this one. So the last parameter, you can ignore it. And you can see, so the first value, it's the value it's going to return. So it's going to return a color. So it's going to return a vector 4. The first parameter here is the first argument. And it's a sampler, which is a reference to a texture. So in TouchDesigner, we're using std to the inputs, which points to the first input. And then the second argument is a vector 2, because it's like a 2-dimension coordinates. So what the function expects as arguments, it can be the same, but it doesn't have to be the same as what the function returns. And then
Can you repeat that last part? You can use a position or a second argument. Doesn't have to be what you.
I mean, what I mean is the arguments a function needs can be different from what it returns.
As long as you output what it's expecting.
Yeah, we're gonna maybe I'll do a quick explanation about functions. That would make sense.
For example, like you say, it's looking for a vec4, or you're declaring that this function is a vec4.
Yeah.
You can declare two vec2s inside that vec4.
Yeah.
To output.
Yeah, exactly. So just as a quick example of functions, okay, maybe first I'm gonna quickly finish. Any more question at the moment, or people who are stuck? So I'm gonna quickly finish to show. So we say we wanted to animate the kind of center of the effect. So what we're gonna do is, instead of using this fixed vec2, which points to the center, we're gonna declare a uniform, and we're gonna call it u effect center. I'm gonna save that. And now what I can do is say center equals u center. Center equals u effect center. And now if I, oops, sorry. And I'm going to create a uniform called U effect center. Okay, so I did something weird, but and now you can see I can like animate this value. It's gonna animate the.
So a float is just one value?
Yeah.
And if you need more values,
you use a vector.
Okay.
Yeah, yeah. Sorry if that wasn't clear. And a vector is a collection of floats because you can also have single value which are integer. So like no floating point, just 1, 2, 3. And you can also have vector of integers which are called IVEC. But we're going to see that later. And now I can like do the same as yeah, and I'm gonna to do something different. I'm gonna put down a bit chop, and I'm gonna output yeah, the pulse. Yeah, I'm gonna output the pulse. So I'm just creating a little animation for this effect. And now what I can do is kind of reference this. Okay, I'm gonna make it faster. Oops. So now I kind of have this like little like rhythmic pulsing thing.
So it's like a way to group everything, like have everything.
So a quick note about null chop. So they don't do anything, and the nice thing is that now I can like add operators before them. I can like do more operation, and it's not gonna break my reference. So it's just a way to reference something that I think is like not gonna change, and then I can like do more edits in front of it without breaking the reference. So I think in general it's good practice to kind of create nulls and reference them, and you don't have to like all the time kind of rename your references. Yeah, so this little effect chain. So bit, it sends one sample pulse every. So it's using the tempo of your timeline. So if I do 240 instead of 220, it's gonna be twice as fast. But it's only one sample long. So filter, it's kind of smooth the impulse in time. So if you want to see what's happening, you can put down a trail chop. So if I connect it to the beat, so you can see that's like what this is generating. And if you connect a second one to the filter, so now it's doing that, and that's why I kind of boost. Yeah, so not a viewer scale, but otherwise that's why I boost the amplitude. And you can define, so the filter width is going to be like what's the window it's getting smoothed. So if you have like a bigger window, it's really gonna. I think in general, if you do any kind of audio reactive visuals and you have like this like super fast Alex, you want to kind of filter and smooth thing a little bit, so it's like less less jittery. So yeah, that's like what this thing is doing.
Why use pulse filter map and not just an LFO with amplitude?
I think it's like with an LFO. I mean, I could also do an LFO and kind of clamp it to 0. It doesn't matter.
Yeah,
It's just like.
gotta do some math.
I mean, it doesn't matter. I can like.
You don't have to do the math. It just starts to look weird.
I think there's like a lot of different way. So if I do an LFO and I put down a limit, and limit I can clump it between 0 and 1, and that's gonna. Oh yeah, I want to negate it, so I'm gonna clamp it between -1 and 1, and that's kind of the same. So. Okay, so
I have a question. In texture, if you have on the point argument values that range from 0 to 0.5, what happens after that? I'm clamping the texture. Just
oh yeah, so then
it's extending the edges of the image.
Yeah.
Why is that as opposed to being black?
Well, if you're clamping anything that's bigger than 0.5, it's going to be 0.5. So it's like all the pixels that are going to repeat the same value. They're going to have the same value, which is 0.5. So you're going to have the edge of the half, the middle. Yeah. So just to... So if you're, yeah, for people who like are good with that, just very quickly, I'm gonna demonstrate. You're Iago, right? Nice to meet you. What Iago was saying. So I just created a new one. I'm like kind of doing the same. I don't know if clamp works on vector. Maybe it does. Oops.
Using the built-in clamp function?
Yeah, so clamp is also a built-in function. Yeah, so clamp only work on. Oh no, I think it needs to. Yeah.
Yeah, you might have to declare.
Oh yeah, so it works on vector. So clamp, it's gonna kind of limit your value between a range, and you can do it with floats or you can do it with vector2s, and then you need to provide vector2 as arguments. So what I'm doing here is limiting the UV after they don't go bigger than 0.5. So all the right part, instead of going from 0.5 to 1 and kind of showing the rest of the picture, it's going to be 0.5. And so with this, you can do like a nice kind of a reveal effect if you define a vec2 called uLimit. And then you use that here. Oh, this doesn't work. Oh yeah, 1 and 1. Yeah, so now you can see you can like kind of reveal the picture, revealing the edges. So yeah. And now very briefly, so I want to point your attention to the remap top. And the remap top, what it does is you can specify in the second input kind of modified UV coordinates. And so we could like use a ramp in the second UV coordinates and like kind of also warp the picture. And it would be like a similar effect. So just to show. So if I do this, it's using like the same value for X and Y. And it's kind of like, I'm gonna, so remap your kind of giving modified UV coordinates in the second input, and then you can like also do this these different effects. Anyway, just a quick note to say that a lot of things, so all the tops are kind of wrapper for GLSL shaders, exposing useful parameters. And in general, like Touch is pretty good at providing tops to do most things, so you don't need to do them in GLSL. But you can still like kind of extend, and also you can compact multiple operation into one GLSL shader, which is going to be kind of lighter, because each top consumes like a tiny amount of CPU. And so when you have like very big projects and you have like a lot of like operations and you need to optimize, then it can be good to kind of replace networks using like fewer GLSL tops.